Let's look at few of the basic things when it comes to triangles. First, we'll begin with opposite side. If we happen to stand at angle A, what is the opposite side of angle A? So there are three sides, is it not? 1, 2 and the third one. So if we happen to stand at angle A, which is the opposite side? It's BC. Does it make sense? If we happen to stand at angle B, if we happen to stand over here, which is opposite side? AC. And if we happen to stand at angle C, the opposite side happens to be, yes, AB. Okay. Now, similarly, if you have to talk about opposite angles, now say we are standing at AB. So which is the opposite angle? Clearly C. And if you stand at BC, it's clearly A. And CA, it's clearly, yes, B. Okay. Right. Next thing that we need to know is about altitudes. So altitude is nothing but the fastest path from a vertex to the opposite side, or to the ground I have written over here, or to opposite side. Now if I happen to stand at A, what is the opposite side? BC. So altitude is nothing but a perpendicular line from the vertex to the opposite side. So you guys need to know that it is not so for all the cases. Example over here, triangle MNO. So this is the triangle. So this blue color thing is your triangle. But clearly we can see that the altitude from M is not touching the opposite side. It's not so all the time. Okay. So it is an extended line of your opposite side. So to that, if we happen to draw a perpendicular line, that's your altitude. So to be honest, this is not the proper definition. I think this is a better definition. Fastest path to the ground, and the ground being opposite side, if not the extended part of the opposite side. Okay. So here again we have another perpendicular line OT, which is on extended line of MN. And we have NP and perpendicular line to MO from N. So perpendicular line need not touch the opposite side. Here it's touching, here it is not, and here too it's not. So here the altitude happens to be OT, MS and NP. Okay, and over here the altitude happens to be AT. So you guys can think of altitude as the fastest path to the opposite side or the extended part of the opposite side. Okay, so altitude, the idea of altitude you guys have to realize, because many people just draw the altitude to be this. So from all the three vertex you can draw an altitude. So this understanding of an altitude and that this is possible is important. Next is your bisector. Bisector has to do with cutting the side into two equal parts. But this line has to be a line coming from the vertex. So from a vertex to the midpoint of the opposite side. So I have a triangle ABC. With respect to BC, O is the opposite angle. So from this vertex I'm drawing a line AD, and this happens to cut BC into two equal half. That is, if BC happens to be 16 centimeter, BD will be 8 centimeter and DC will be 8 centimeter. Please note that many people get confused with this. It need not divide the angle into two equal parts. This entire thing happened to be 70, this can be 30 degree and this can be 40 degree. It need not be an angular bisector. Bisector, if not side bisector, is something that will bisect a side for sure, but may not be the angles. It sometimes does. When is this sometime? We'll discuss that. But please make a mental note that a side bisector, if not a bisector, need not be an angular bisector. Angular bisector is a different concept altogether. So, and what is this angular bisector? So again, a similar example, I have triangle ABC. So angular bisector bisects angle A into 35 and 35. That is 35 plus 35 is 70. So it is cutting this this entire angle into two equal parts. But as you can see over here, it need not cut the entire side into two equal parts. This can be say 6 centimeter and this can be 10 centimeter. And one more thing is, from all the vertex we can draw bisectors and angular bisectors. It need not be fixed to that, okay, it's always from the top vertex. Again, many people have this illusion that yes, altitude, bisectors, all of this comes out of this itself and they're equal and all of that. So please, clearly you can see this. And I've taught this in basics also. So wherein we do paper folding and we clearly distinguish a bisector from an angular bisector. It need not be the same. So bisectors need not be equal to angular bisectors, but there are exception cases, and the cases being in isosceles triangle and equilateral triangle. In an isosceles triangle, from the vertex containing equal sides, if we draw a perpendicular line, it acts like a bisector, angular bisector and altitude. Again, I repeat, the altitude or the angular bisector or the bisector has to be a vertex containing equal sides. So AB has to be equal to AC. Okay, if AB is equal to AC, right? So these two sides are equal and thus these two angles are also equal. From the vertex containing these equal sides, if we draw up a perpendicular line, this will cut the angle into two equal half and the side into two equal parts. So here AP is the bisector, angular bisector and altitude. An important note, this is true only for the included angle of equal sides. Okay. And at last we have equilateral triangle. Here all the angles and sides are equal. Thus all the altitudes are equal. Okay. And are bisectors and angular bisectors. In equilateral triangle, if you consider, that an altitude is a bisector and angular bisector from any angle, it is true. So remember this, for equilateral triangle, there is no exceptions. It itself is an exception. So all the sides, angles and everything is one and the same. You can turn around it and it's the same. Right? So this is something that you have to keep in mind. Again, you need to understand what is opposite side of different angles and opposite angles of different sides. And altitude, mainly I'm not looking at definition, but the idea of how to draw an altitude and that it is the fastest path to the opposite side, if not an extended part of the opposite side. It always has to be perpendicular. Okay. Next is your bisectors, angular bisector and your side bisector. They need not be the same, but they become same in isosceles triangle from the vertex containing equal side and for equilateral triangle with respect to all the sides and angles and everything. Okay, so you need to pause. All this is taught in detail with your practical folding and whatever is possible. I've done that, so please watch the basics if you need to understand this more. But yeah, it's a small recap and you guys need to know this. So please pause. have a look at all of this. And you need to copy as well.